and the hard drive manufacturer then encrypts the firmware, or encrypts the thumb drive, or encrypts whatever else is left. They do everything they can to stop us from getting to it. All right, so now RAID. Let's go back to this. So yesterday we finished the discussion, at least about RAID and RAID 5, RAID 0, and in the normal realm of anything that's medium to small business versus what you would have in like a very large business like a net app or something along those lines. Those are all going to be custom pieces of code, things that you don't have in software. Like, I don't know of any tool that rebuilds NetApp without trying to get something running again and get it back in the NetApp box. So, but pretty much anything else that's separate, that HP Compact, RAID arrays, JFFS, IBM, all those guys, you can pull those drives out. You can do something with them. There are tools that will automatically read the configuration from those. So UFS Explorer is one of the biggest ones. And for $300, if you're dealing with trying to read configuration files from any of the high-end RAID arrays, right now I would say UFS Explorer has the majority of all of them, and the second one is Reclaim Me. Normally I'd say Reclaim Me's first. Reclaim Me is really good still in the medium to small market, where it's Drobos and things that nobody else has a good configuration for. Not that they don't do some of the others like VMware and things like that, but UFS Explorer, that guy has spent a lot of time building the higher end RAID arrays. So all of those Compact, JFFS, any of those, between those two programs, between Reclaim Me and UFS Explorer, I'm not sure that there's anything that's not covered. Like, I can't think of a single RAID that I haven't done that those two didn't do or play some part of. Now, I have had to go further on VMware. So on VMware, there are some guys who specifically have built only a product for VMware. And so once I get so far, if it can't be done in Reclaim Me on VMware servers, then I do go to specific tools that are very expensive for just doing VMware. And so, and I normally have to look for them, call them, but it's a lot of European companies that write a portion of one that do those things. So now back to where we're at. Most of the stuff I'm going to see is going to be RAID 6, RAID 5, RAID 1, RAID 0. And so all of those and the format for all of those have basically the same layout. I went over the layouts yesterday. I don't know if you would remember and saw left async, left sync, right asynchronous, right synchronous. So anything that's kind of like a Dell server and below is all going to be, in that price range, is all going to be left. They're going to either be left synchronous or left asynchronous. If they're Compact, HP, and further north of that from a price standpoint, if they have a big brand name on them and they're big enough to even start printing their name on their drives, they don't make the drives, they just print a name on the drives. You don't have an HP drive, okay? You have an IBM drive that got labeled with an HP sticker on it or something like that. So, going over that territory, all of those are going to be right. So the right configurations. So I'm going to just tell you right now, I can eliminate 50% of your choices if you just even know anything about the brand, model, money, how big the company is, how much they spent. If I get an array from Ford or Meade or somebody like that, I would expect that they would be a right configuration. And if I get a server that would have been from small, medium business running your standard Microsoft server somewhere with a Dell server, then you're looking at left configurations. Does that make sense to you? So I can eliminate them almost immediately if I know anything. So I'm going to go over RStudio. RStudio is a great tool for a couple of reasons, and it's besides the price range. The one nicest thing about RStudio is that I found when I'm dealing with a RAID array is I have never hit its limit. So like in other tools, like I'm just going to give you a quick example. You don't have to execute this yet. This one, if I wanted to do them, I got 14 drives. If I have more than 14 drives, I'm SOL. I can't use this tool. Same thing in, now this is an older version of WinHex. And in Specialist, there is a RAID reassembly and 16 drives. Like after you get past that, you don't have a choice. Also, though, the really nice thing is, so this little table over here, this is all of your arrays. This is almost all of the existing arrays that are out there. And so these are all variations of those same 4 items, with the exception of things like when you get to what's called 5EE. A lot of times those are going to be your delayed parity. So those are going to be your higher end ones like HP Compact, something like that. So here's a delayed parity right here. So those are the variations of the higher end ones. But all the other ones, so here's your RAID 6, here's your RAID 5s. These two are going to be in an expensive box. They're not going to be in anything cheap you're going to see in the middle to low end market. So what you've got is from here to here. And HP Compact is its own thing, so you don't have to figure out the HP Compact. There's a lot of tools that'll figure it out for you, even some affordable tools that'll figure it out for you. So as you can see, when you look at your entire list, unless you've got a brand name stuck on something, you've got 1, 2, 3, 4, 5 possible choices at best. And so the rest of the stuff is all going to be expensive. So I say you have 4, so one of those is some variation of that dynamic. It's because dynamic, I told you dynamic arrays, they're ridiculously easy. You just plug them into RStudio and it figures them out automatically. This, you have to know the layouts. So you have to know your order and your layout and deal with it. In RStudio, it doesn't need it to even know the order. It does it on its own. It knows the order of them in the dynamic table. Anyway, so that's one of the biggest things is that with RStudio, and you can all launch RStudio now. We're going to launch RStudio on the right hand side, and you're going to come back to this screen. Now, again, this is a ugly screen, and I have printed every screen print. There's in the lab area in the back. I have done every single thing that we've talked about, every picture, every screen that I'm about to do. It's all there step by step in the back of the book. But I'm going to try to walk you through the ugliness of this program and try to make you understand what it is and where your mistakes are. Because I can tell you where you'll make a mistake every single time doing RAID arrays. Because there's like 2 places. Everybody always makes a mistake. And even I mean, doing it for so long, you just fall, sometimes it just isn't obvious what's going on, and sometimes you click the wrong button. So in this area here, these are your live drives. And then this is all your information panel stuff over here. And then on the fly, you can create things, and this panel will change depending on what you have created. There are newer versions of this tool, and the newer version also not only has it added things like APFS and some of the other stuff, encryption, they've added a box that I cannot figure out how to use and it's never worked. When you make a RAID array, there is a little button above the top of the RAID array configuration that says, see if I can solve the RAID array. And you click it, and I can't figure out what it's doing. It just goes off in the never never land, never comes back, never gives me an answer. I've left it for like simple arrays. I've thrown simple arrays at it just to see if it can solve them, and I've never gotten it. So I just stopped doing that with their tool. I just don't do it. Maybe somebody else can figure out how it works, but I've never had it solve anything. And it always looks like it hung up. So I can do it faster than RStudios can, so I don't know what they've been doing. Maybe they'll fix that button someday. But it is the only, at this point, even though they've added that automatic thing, I say it's all manual because that's the best way to do it. I can figure it out faster than any automatic tool. The nice thing about automatic tools is they do solve your problems most of the time. When I started this class back in 2007, there was no automatic tools except for RAID Reconstructor. And RAID Reconstructor is the only one that tried to figure them out by entropy. It didn't even use any of the same methods anybody uses today to solve the RAID arrays. And I'll show you what entropy is and how it works. It does solve the RAID arrays. It can still solve them today. The problem is flaws in the program. So, and maybe it's because they're trying to make more money. I really don't know. Every once in a while, runtime has surprised me with buttons that don't seem to be what they represent or what they should represent. All right, so off on my tangent. So in this box, you can plug in logical images. So you could make an image of a hard drive, a DD image, just like we've been doing with the Mac OS and the other ones that we've looked at. And you can mix them up with real hard drives or USB hard drives. So I could have a USB hard drive and plug it in, and it'll show up in this list. And I can take real hard drives and plug them into my SATA controller, and they'll show up in this list. Then I can take DD images and plug them into here, and then mix them all together and make a RAID array from all different sources. So that makes sense to everybody. Now here's the best piece of advice I can give you right now is this. If you are going to do RAID arrays for a living, go to eBay and find, do this, because these were expensive. Like, these were like $3,000. So I am looking for a RAID, an Adaptec RAID 16 port controller. I'm not kidding you. This was like $3,000 for this controller. And now you can buy it for 30 bucks, 50 bucks. I buy them all day long. Now for $50, I buy them. The expensive part of this is the cable. See this right here? Back in the back, there are 16 ports. And they have a mini cable that comes out and goes to SATA and to SAS. You do not have to buy a separate cable for SATA. SATA is upwardly compatible with SAS. So SAS connectors can plug into SATA drives. SATA, not the other way around. You cannot take a SATA adapter and plug it into a SAS drive. Do you understand what I'm saying? So SAS is better. SAS is the servers-based serial cross SCSI. So that physically is going to be the better connector, the better controller. It's a high-end controller. I mean, these things are what were in HP Compact Surf, things like that. These were high-end, not this particular one, but this, because Adaptec didn't make those. I just searched for Adaptec on purpose because I know we can get the drivers for them for almost every OS. I know we can get them, so I can run them on Linux, I can run them on Windows, I can run them anywhere I want. You can combine these boards together. If you buy 2 of these boards, you have 32 or 32 drives that you can do in an array. If you buy a third one, you can do 48, and so on and so on and so on. You can just keep adding to your drives until you get high enough up. So if you get 64 drives, I promise you, even though USB supports 128 devices, you'll never get 128 devices plugged in. It will they'll fall offline while you're looking at the drives. So if you're doing them over USB, they will fall offline while you're doing them, and you won't even know that your drive fell offline while something's searching for an algorithm or you're looking at them. This is your solution. Buy these. If you get lucky, find one that has the cables with it. Because the cables like this, like here's a 16 port with 1 gig of RAM with the cables and an extra battery. This is worth the $69 because these cables right here is a couple $100 in cables. Those cables are expensive if you try to find them and buy them by themselves. So if you get one that you can find the whole controller and the whole thing, I mean, that is amazing to me that I'm going to get 16 ports on a PCI controller, and it was way better than anything else I can plug in. I'll be plugging SATA drives into it all day long and just hot swapping them all day long on my machines, bringing them up and running and doing logical recoveries. Everybody understand what I'm doing? Very simple, very straightforward. Motherboard sitting on a table, slap in the card, move the card around wherever you want. So I have like 4 of these that I just moved depending on the quantity of drives that I'm dealing with. So if I got 4 drives in a RAID array, it will also be the fastest way to communicate with them, because you do not want to be doing it over USB. That is really slow. So trust me when I tell you, you don't have to have an expensive motherboard. You can have a $50 motherboard with an AMD chip on it. $100, huh?
I was about to ask.
Yeah, like, no, $100 motherboard with crap on it, throw a hard drive on it, boot on Windows, Linux, whatever you want, or a thumb drive, and throw that in there, install the driver, and you're done. Bam! I've got all my drives active, and then just run whatever software you want to run on it. So all day long, that's what I do, just like we've been doing in the lab. Rip stuff out, put it back in, move the motherboards around, grab stuff wherever you need to go. So look for any of these other ones. The other ones, if you want to go beyond, I'm happy with Adaptec. Its controller is pretty good. It's not perfect, but, and if you can get a 16, there is also a 32 port, so you can buy multiple cards depending on however much that they cost. So you can buy ones. There's 8s. There's, I don't know if I would go for a Sun. That would be a little bit harder to get all the drivers for. LSI bought 3Ware. That's a problem, because 3Ware was one of the best companies at making RAID arrays. And you can still go back and get an old 3Ware. And so if some of those have way better control mechanisms in them, but I mean, look at, I mean, even if you are just trying to do SATA, I'd still do SAS. But even if you are trying to do it, it's $14 with the cables. I mean, you're going to argue with some of those things to set up RAID arrays and get stuff running. So that's my best piece of advice. Stop using SATA connectors on your motherboard. Start using SAS connectors on a RAID array. They treat them as individual drives. You don't have to set up RAID ever. You just plug them in and they'll just come up in the system. You do not have to set up RAID. You don't have to mess with the BIOS on the card at all. If you're just plugging drives in, they'll just come up in Windows, as long as you have the driver installed. Okay? That's how I get all the drives up. So literally just walking around slapping them in. And the problem you have is power. You want to make sure you've got good power supplies, and you can just plug them all in individually. So I'll run separate power supplies for my drives. I'll bring up all my drives, and so I have a bench, and underneath the bench I have shelves, and then I have the cables running into the machine behind the shelf. And so I'll just put all these hard drives and stack them all up so that there's airflow between them on the racks, hook up all the power. If I need 2 power supplies, 3 power supplies, I'll hook all those up, because if you put all that weight on one machine, you might cause the short in the power supply, and it might actually go down while you're running. It's a lot of power for 32 drives to be running. And so I'll just hook them all up on a rack, have them all connected out, and then once they're all powered on, power the machine on, and then power everything else on together. And so I'll just do them all at once. And they're just running in the corner, making a lot of noise, creating a lot of heat. Okay, now back to here. So once you've got all your drives and you've got them in the list, now you can start mounting your image files. Now I have a real RAID array that came from a real hardware controller. I made images of them, but I'm carrying all this weight around on the laptop, so I've got 8 gig images. So I want you to open image. So click the button that says open image. We're going to go to this directory. It's called Data Recovery Images, and then, surprise, surprise, one called RAID 5. And then go into the RAID 5, and there'll be another one called version 2. So once you get to that directory, you have to change the little drop-down box again, because it doesn't recognize DD, so you got to say all files. And then you should have something that looks like this.
Where's the RAID 5?
It's right under, so Data Recovery Images, RAID 5, and then there'll be a RAID 5 version 2. Do you see that directory? Yes?
RAID 5. Yeah, okay.
Got it? Okay.
RAID 5V.
Yep, V2. And then so click on that folder, and then click all files. And so I purposely name everything. I mean, obviously I could have fixed these years ago. The whole point is, there's like 27 names for DD. And DD seems to be the easiest one, because you usually make it with DD, which is disk dump. And it's literally a raw image. But surprisingly, no one supports .dd as the name of a file. Why? I have no idea. Like, why didn't you just add that out of all the 27? Right? It's like, why did you not just add that? And in this list of files, you'll see I have an MD5 that I made of all the files, and then there's headers. The headers are actually the same thing as the as FTK's text file, so we don't need those. We only need the DD images. And so if I was working on a RAID array, even if I had 32 drives, I probably have 3 or 4 drives that died. So maybe I need to make images of 3 or 4 drives. I would still only have a handful of them that I have to plug in dynamically from image files. So you can hold down the control key and select just the DD images. You don't have to load them one at a time. If you just hold down the control key and you select the DD, you'll see it add them to the list like this. And so it just basically puts quotes around them in the open file list. Not every tool does this, too bad. So some of them you have to do them one at a time. You have to select every single thing. Okay? So if you just select those 3, we're going to mount our 3 drives that we have repaired. And I did image them on deep spars, and then I did turn around and image them with FTK and just wrote those as DD files. That's all I did. I did the reverse of opening an image. Okay, everybody good? Click OK, open, and now it will add them. So the first step of RStudios all the time is plug in all your drives. So you always should do that before you do anything else. It just makes life easier. So you'll have your image files, you'll have your physical hard drives, and you're also going to create a fake RAID controller. You got to be careful not to mix them up. When you're working in the interface, you're always selecting something in the interface, and if you select the wrong thing, it'll let you take action on it. It'll just be the wrong action. You won't get the result you expect. But it's because you make a mistake in the selection process, and it's easy to do. Very easy to do. Okay? So now I've plugged in these 3 drives. Now immediately, it doesn't make any difference what I had numbered them. I could have numbered them anything. You know which drive is the first drive because it had an MBR on it. Right? Now, if you start plugging drives in and you don't know what any of this stuff is, then here's the cool thing inside, and I do spend every day doing this. If I plug in hard drives, I look at it in hex. You need to start looking at it in hex. I know it seems scary if you haven't spent a lot of time with a hex editor, but you'll also never get better at it if you don't start looking at it. So you've got to get used to what you see and know what your stuff is that you're looking at. So the very first thing I do is I come to an image, I'll highlight the image, not the partition. If you see a partition, it's great, it gave you information. But don't use the partition ever. The partition is not what you want for any of your discovery process. It's only your resultant that you want to worry about a partition. So I highlight the image, and I do this for every drive in my array. I'll go and I'll look at it and I'll see. And now at the beginning of the process, let me back up a step. I've already repaired drives and I've plugged them in here. However, before you ever start working on a RAID array, you should find out if any of the drives in the RAID array are blank. I cannot tell you how many times that if you do all the work at the end of the week, you don't have the quantity of drives you need to calculate it. So you need to do recon ahead of time. You need to do, not recon the tool, recon as in go look at and do reconnaissance and figure out whether or not you've got everything you need to rebuild this RAID array. Because I get 32 drives in, what happens if 3 of those drives are blank? Somebody swapped them at the office. What if the Dell tech support guy said, hey, I need you to hit wipe on that drive so that we can see if it's a warranty replacement? I have had that happen.
Or the guy that says, oh, you charged by the hard drive.
So then they're erased. They're gone. You're charged by the drive. So they're gone and you don't have them and you need them all. So do this, I promise you, at the beginning of every process. So you might have a stack of dead ones and you figure out what the dead ones are. Don't fix those first. Go find out if all your drives have data on them. So right click, and when you go down to the bottom, near the bottom, there's an item called View Edit. Control E. So you can hit Control E on every drive as you're going through it and it'll pop up an editor. And it's a true editor. You can literally edit your data and destroy your data by accident if you tried. Okay? So this is a full-fledged editor. It has templates in it, so you could look at your master boot record and apply templates, see what data is, the whole thing. Anyway, I don't want to get into all of that portion right now. What I'm primarily doing is this. I'm looking at the first sector. You can see the first sector. Does it have a 55AA? If there is a 55AA, you know you have a MBR, right? Also, what else do you see in here that tells you any information right away? Just like on the deep spar, I can go and see the partition structure and I can say right away, hey, I've got an 07, so I know what my file type is, so I know that this is a NTFS volume, right? So this will help you, especially on RAID arrays, because on a RAID array you sometimes will get a strange number and the strange number might not make sense and you have to go look it up in the table and see what it is. Oh, it's Solaris, it's SCO, whatever, I don't care. I'll rebuild the array. You can still do all the rebuild even if you don't support the file system. Even if RStudio doesn't support it. You can still logically put the entire thing together and export it to a single file and then mount it in a Linux box. You can do that. Everybody understand so far? So I can do all my recoveries this way. All right, so now the next thing is I'm going to scroll through the drive. I scroll through every drive and I make sure I've got a chunk of data. So I've got a pretty good chunk of data, I got some missing data, then I got a chunk of data, I got data, missing. Now, it is common to see like half of a RAID array be blank. If they have like 137 terabyte RAID array, half of the RAID array might be blank because they haven't written any data there. So that's why part of this might be blank. So get used to seeing that, but I do have a chunk of data. You may only have a array with 20% of the data on there. These things are big things. So I'm just making sure I have data. Everybody good with that idea? Then I can close this window, go to the next one. And then I verify that the next one has data. So I do exactly the same thing. Hey, look, is it about in the same place? It should be exactly almost in the same place. You could also do this. I have done this. Let's say it's a RAID 10. So you've got 2 drives that are striped with 2 drives that are mirrored. You need to eliminate the 50% of the drives that are the other copy. So that means 2 of those drives are identical and the other 2 drives are identical. Does that make sense? You only need a pair that are not identical. Everybody good so far? What you do is I just pick a sector and I pick a cell and I take a screenshot of this. Then I go to the other drives and I look at that same sector. I'll go to that same sector and then pop down to that spot and say, hey, is that the same? It better be the same on a pair if it's a RAID 10. The only reason it wouldn't be is one of the drives fell offline earlier than the other drive, and now you're trying to figure out which ones are the right ones. Does that make sense? So, but that's how I eliminate duplicates. I go look at all the duplicates, mirrors, and I remove them, and I make another stack of those drives. And those drives I'm going to ignore for now. If something turns out to be wrong here, or I've got some corruption down here, then I might go verify that drive. But this is how I see. The other thing is, if this area on a RAID array, everything is going across in a stripe, RAID 5 or RAID 0. So if you have data here, then there should be data in that spot. Even if it's not identical data, it shouldn't be identical data unless it's a mirror in that same spot, so you can always check the same sector. That also means the same for zeros. If I have a chunk of zeros here, I could go look at another drive and make sure that they are zeros here. They should be 0. If one is 0, it is very unlikely that it wrote a stripe and that that part has data in it and the other one doesn't, because they go together. Everybody good with that? I know it's a lot of concepts here, but the whole point is just making sure you've got the correct thing and you've got all the pieces. So I look at this one, then I'll go to the next drive. I'll do exactly the same thing again, and I'll make sure if I have the same equal data on all of them and that I don't have something that's wrong. Okay? So now I would have had a bad drive somewhere in the stack, and that's the one that I've got to repair, but I make sure that all of the other drives have their data on them. And let's assume one does not. How many drives do I need in a RAID 5 configuration in order to do a rebuild? How many do I have to have? Well, I have to have 3 to create the RAID and to have a real RAID. How many do I have to recover from?
All but one.
All but 1.
Yeah, all but
X minus 1. So if I have 10 drives, I can have 1 0. I can have 1 drive that's completely 0, and as long as 9 drives have data on them, I can rebuild it. Everybody good with that? Because I can make a missing disk, because the parity stripe, the redundancy is 1 drive dies, I can still recreate A plus B equals C. So I'll do that in software. And if you have a missing drive, it is slower to extract the data. It will be slower, because the software is going to do the recreation on the fly. If you have all the drives, it doesn't recreate it, it just spits out whatever you have. Okay? Alright, so now I have sufficient data in all of these drives in order to do an actual recovery. I have all 3 in a 3-drive array. That is one key you must know. How many drives do you have in your RAID array? If the dude lies to you or he doesn't send you all the drives, you've got a real problem. You have to know how many drives you have in your RAID array. That is the one thing you must know. So a stack of 4 comes in, I better have all 4. They better be 4. Alright, I'm going to point one other thing out that is not important for this particular recovery, or even a lot that I do by hand. I don't often go looking for them unless I've got some complicated thing that didn't work out. Again, I'm going to go back into the hex editor. So go back and view a drive. And I'm just going to tell you from habit that this will work a lot of the times if you're looking for something. You grab the scroll bar, go all the way to the bottom. Now, when you get to the bottom, somewhere in usually the last 100, 128 sectors, there's some sort of configuration file. So it may take you a minute to figure it out, and you can use page up to do this. So you can start paging up, but you'll see eventually somewhere within 128 sectors of the end of a drive a configuration. So most drives, this is even a cheap one. This is a cheap high point controller. And so this one still had a configuration at the end. Now, whether or not you can read them or not, that's a different question, because some of this is binary. And so, but every once in a while, like some of the higher end RAID arrays put serial numbers of the drives. So let's say you have something more complicated. You've got 16 drives. It might be 8 are in one array and 8 are in another array. And the configuration will tell you which drives by serial number belong to this array. So you may have 16 drives and they don't all belong in the same array. There are 2 arrays. Everybody with me? So I can look at serial numbers and say, oh, all these drives all go in this one array and these other 8 drives go in another array. But now we're in a little more complex situation, because now we're in a situation where the client obviously didn't tell you, I had 2 arrays, and you're doing 2 recoveries. Good? Good. All right, back to here. Now, once you've confirmed you have everything that you need, and I am not kidding when I say I get a yellow legal pad out for a complex RAID array, I will get a yellow legal pad out and I'll make my notes. And because it's hard to remember yesterday, it seems like a long time ago. You know, when we first met, it was only 4 days ago. Seems a lot longer now, but it was 4 days ago. So you need to be able to write that stuff down and make notes. And you may also not be the only person working on it. Chase in my office also works side by side with me. I pick up where he leaves off. We're like 2 peas in a pod. I can do half the work, he can do half the work. All right, so next, we're going to create a RAID array, a fake RAID array. We're going to make a controller. So in this tool, there is a box at the top. The menu item says Create. These are your options for the types of RAIDs that you have. So we don't have to deal with a mirror. We don't have to deal with the volume set. That would be concatenated drives like JBODs and dynamic and a few other things that happen. We're going to be creating a virtual block RAID. That's what we want. So make a virtual block RAID. Now, this is something stupid that this program does. And I don't know why they thought this was a good idea. What is the name of the virtual block RAID that it made?
RAID 1.
And throughout this entire process, the next one you make will be called RAID 2, and the next one will be called RAID 3. And people always seem to think that that's like, it's a terrible name. You can rename it. So for people who do get confused or need that process to be done well, you can come over here to the properties, and on the properties tab on the bottom one, it tells you the name of the RAID, and you can click in there, and I can call this RAID 5, and I can give it a real name, Sam Test 1. That way I don't accidentally think, and then when you come back and you click back in the first box, it'll rename it. Because it is annoying that if I keep creating RAID arrays, I just keep having these numbers, and it really does help if you're going to make a separate configuration to name it something specific, and to come back and that way you're not confused with which one you're on. So if Chase makes one, he calls his Chase, and I call mine Scott. Alan Moulton, that's what Sam is. So, all right. Now I have a fake controller. This is pretending to be the BIOS of the controller. When you boot your computer, you can usually hit like Control A. Now I will also tell you, if you have an option and the dude is smart enough before he sent you the mystery box, maybe you can call him. You can say, hey, you stopped that machine. Can you hit Control A when you're booting and tell me what the configuration says? And bam, you've solved your problem, because it'll tell you what drives were in it. It'll tell you the serial numbers of the drives that were in it. It'll tell you the configuration that he had and how many stripes he has. That'd be the real question you want to ask him. What's your stripe size? Oh, is it 8? Did you play with it? So at least from this standpoint, we're now making one that you would be dealing with in the BIOS. Now, here's the cool thing for RStudios. You can plug drives in either by dragging and dropping them or right-clicking. If you right-click, then the menu will remove the items as you use them, so your menu will get shorter and shorter as you add your drives in. If you need to know, like sometimes I know which drives go in what order by their serial number, if you do know them, then over here in these boxes, when you click on the drives, you can get information about the drive and it'll give you a serial number in a lot of cases, so you'll have the data that you need. And so I make a list and I post that list there so I know which drives they are. When you click on something else, you have to make sure you come back to where you were. So I click on my virtual block RAID. That's the confusing part. That's where people mess up all the time. But you can see your serial numbers if you knew the drive's order. So if you right click, we know because there's a partition on this one. This is another mistake everybody makes. Sometimes they accidentally click on the partition because they see it. It is not ever the thing that you want to click on. You always want to click on the thing before it. They are pairs. And so if you have partitions, you'll see the image, then you'll see the partition. So you always click the thing above what it is that you think gives you information. So since we know this is the partition, we know which drive is the first drive in the set. Does that make sense? So I will select that drive. Then you need to add the second and the third drive. And it wouldn't make much difference if I changed the order or did anything. I really can't fool you, but you'll figure it out pretty quick. Right click. And now you see your menu option is shorter. Now add the second one, then right click, and then add the third one. So you have now, So you now have added all 3 of your drives. Okay? Now, we need to set up our RAID array. So over here on the right hand side, now I do want to point this out to people again, this is very important. We have a very small RAID array. We have 3 8-gig drives. So how big is our RAID array? How big is the actual size of our RAID array? I have
RAID 5 is going to be
16 gigs. So it's X minus 1 because the parity is taking up the space equal to another drive. It's not a parity drive. It's equal to the size of the other drive. So it's X minus 1. Okay? There is a button that says apply changes immediately. Don't do it if your RAID array is large right now. Because if you did that and you're not done setting up your array, every time you click a button, it takes an hour for it to recalculate the layout. So you wait till you're done and you set this thing up the way you want to, then you can click apply changes, and then every time you make a small change, it may take a while to set it up. But if you have a 16 terabyte array, I promise you when you click that apply changes immediately, every time you click a button, it'll take 30 minutes before it comes back. It will slow you down tremendously. Okay? So now, right now, what kind of RAID are we?
Well, 0.
What kind of RAID do we want?
5.
RAID 5.
So set that to RAID 5. Now it will show you your parity. And so now it's added the parity and it's already made a selection for you. So by default, and I will always tell you if you start building RAID arrays, always start with 64. 64 was the default, so I stick with the default for all RAID arrays, and then I work my way backwards because size isn't the problem, because your top portion will still look correct. Even when the size is wrong, you may get something else that's different, but I'll stick with 64 to start with, and then depending upon what else I have to deal with, I'll change my block order. Now, remember the order that I showed you yesterday, there's 4 primary options, and then there's 1 custom option. And the custom option would be like if I had a compact delayed parity. I can make it, but I've got to do it by hand. It doesn't do it for you here automatically. The new version may try. So I'm going to leave all the defaults the way I have them. But this is obviously a left configuration. So you can see right away that I'm dealing with a left configuration. This one's left synchronous. If you look in the book, you will see that the picture that I previously gave you matches this exactly. Okay? So we're going to leave it like it is. I don't know anything else about this RAID array. This is the most that I can possibly guess at this particular point in time. Everybody good so far? So now, I want to be as quick as possible at figuring out the configuration. So I really would have only spent 30 seconds. Even if I'd had 16 drives, maybe it would have taken me a minute and a half to plug all this in, do this layout up to this point. So I'd be really quick at getting those things in once I've repaired or gotten everything done and I've got all the drives I need. So now I only want to look at graphics. Every single system that I've ever looked at has got graphics on them. You may not know what the graphics are. Like I'm normally looking at JPEGs because they're quick and easy and they're easy to find. But if you work for movie studios and stuff like that, you may, like you had a DPX file. If you have something that can process DPX in this tool, then that might be worthy of selecting. I've done work for movie studios before and they use Targa files during some of the render stages. So I needed to know it was a Targa file. And a hex editor told me that because when I opened the drive up in hex, I could see in the MFT entries, you can see Targa as the extension for the files that you're looking at. Like, what kind of files are in here? Okay, everybody? All right, so the next thing that I would do is this. You're going to come back over here. I now have all of this on. Do go ahead and hit Apply Changes Immediately. That way, every time we make a change, at least at this point in time, we know going forward it will make it for us. Okay? The next thing is, I'm going to come all the way back over here. Now, you'll see some spare space over here. So there's some extra space it doesn't know at this point. Also, look at this log file. When I plugged the drives in, I got an error. What's the error say? So partition at 63 extends beyond the disk bounds. What does that mean? Why did I get this error?
Concatenated?
No, it's not because they're concatenated. What partition at sector 63 extends beyond the disk bounds? Right, so in the original partition structure in the MBR, it said, I have a partition, and how big is my partition? How big is my partition? How many drives do I have?
16 gigs.
My partition is 16 gigs, right? So I have 3 drives in a RAID array, minus 1 is 16 gigs. I made a partition that's 16 gigs. How big is my hard drive?
8.
It's 8 gigs. So when our studio loaded the image file, it said, oh, I saw the MBR, and the MBR says you have a partition. Your partition is 16 gigs, but that's impossible because your drive is only 8 gigs. So that's the reason that this error exists. And you'll see these things all the time because all of the individual drives are not a unit. They have to be together in order for all of it to come back to life. So you'll see reports from programs all the time that say, oh, this is an error. Some of them will ask you to fix it. Do not fix it. Do not fix, especially if you're on a live drive, do not fix it. Because now you have now made your partition, it'll go back to the MBR, and it'll make your partition an 8 gig partition. That's not good. It didn't destroy any data, it just destroyed your MBR. And then you got to recover from that. Everybody good? All right, so you have to think through those things. So now, we're over here on the virtual block RAID. I do not want to play with partitions at this point. I want to play with the set of drives as a whole. So they're plugged into my RAID, and the entire thing is treated as a whole. Okay? So my options are this. I'm going to right-click on here. Now, if I had said open drive files, which I'm not in a spot where I can do that because I'm on a RAID controller, not on the drive itself, not on the partition, that would try to open MFT entries. You can, and I have by sight figured out what's wrong with the drive just by looking at MFT entries. Because there'll be corruption, there'll be things, you'll get a tree, there won't be an administrator, there'll be directory structures that won't have files in them, things like that. You can figure them out, but it takes a lot longer. So I wouldn't try that. You can do that as a more advanced, I'm doing this later. What I do is I come to scan. Now what does the scan function you think do in our studio? What would you think the scan function does?
Just look for signatures.
signatures?
Looks for signatures. So the whole point of the scan is to do carving. That's its primary reason. There is a way to trick it to not do carving and to only look for MFT entries. So if you turn everything off, it'll just search for the blocks of the OS you have selected. So you come down here and you say scan, and now it's going to say, okay, well, what do you want to scan? And you can specify the size that you want to look at. I just leave it for now. You'll notice every operating system, and as they added more things in the newer versions, there'll be more. So every file system that it supports will show up in the list, and when you want to get rid of them, you have to uncheck them every single time. It doesn't remember that you unchecked them. You're starting all over again every time you do it. So here's the thing. The more time, the more file systems and the more stuff you give it, the longer it will take to scan. So I want it to go as fast as possible. So what is my file system for this drive? So turn off anything that's not NTFS, because we know that already, and we don't want to mess around with something that's a HFS if it's NTFS. So if we know it's HFS, only leave HFS. So uncheck everything else. So you only have NTFS. Okay? Next, see the known file type button? Click that. Now everybody probably has this. It's probably all selected. Is it all selected for everybody? All right, so here's the thing. This is a huge database. Look at all this stuff that's in here. If I tell it to go looking for these headers, it's going to take forever to go look for every document that ever existed. That's a lot of stuff to keep on going through, right? We don't need all that stuff. I don't even care about that stuff at this point. These are where all the other people make big mistakes because they're building a tree off of a RAID array. It takes 4 days. Then they look at the tree and they go, oh crap, it's wrong. Now I got to run another test. I need to get the answer in a couple of hours from the time that the company gives me a RAID array, because it's going to take 5 days to give them the data. So I need that configuration as quick as possible. Once I know the solution, I can send a sample of photos to the client and say, pay me and send me a RAID array, and we'll give you all your files. That way I'll know my success rate. Does that make sense? If I have imaged on the deep spar and I have recovered, which amazingly a lot of the times actually works, when drives die in a RAID array, you either get all or nothing. When they're dead, they're almost never like, oh, it's only 10 sectors. I didn't copy. Most of the time, I'm actually able to copy almost the entire drive once I've repaired something. It's not as bad as it is in the individual drive world, because of the way that the server's running, their drives aren't taking the abuse that they are. So I typically am getting that information back a lot more contiguous. So here's the first thing you do. I don't want to look for all this stuff, so hit clear all. What do I want to look for in this recovery?
JPEGs.
JPEGs. So they have a graphics option right here. So click the plus on the graphics. And then I click on the first one. This is what I do to make it quicker. You click on the first one, but don't check the box. Just click on the first one so you're in the box. And then hit the letter J. And it'll jump down to JPEG right away. So then all you need to check is, we don't even use JPEG 2000 anymore. That's not even a current one. So just check the bottom JPEG one, this one right here, and it will automatically check the second one. So there's 2 of them that it'll check. JPEG camera and JPEG image. So there'll be 2 check boxes. Okay? I want to set that as the default so I don't have to click this button anymore. Luckily enough, it will remember this as a selection here. So there's a button at the bottom that says set to default. So set as a default so that it never ever has to be asked again. And we're going to run all of our tests with just this one setting. Now if you wanted to, you can check any other box you want, but what's going to happen is when it carves data, it's going to number the data. And if yours is the same setting as mine, we will have the same number for the same picture. If it is not, when we go to look at the data, your number 546 is going to look different than my number 546. Okay? All right. That's it. That's all I want to do. So click OK. Now I leave, even though this does take more time, I leave the detailed scan open, because the detailed scan, I only need a sample. I don't need to process the whole 16 terabyte of a RAID array. Once I get about 2,000 pictures, I've got a good sample. And maybe you don't find 2,000, maybe you find 1,000. I'm fine with 1,000. It'll give me a good sample of pictures to look at, because remember, If it's a small picture, 32K, a thumbnail, they're going to work. You're going to see those pictures, and most of them are going to work fine. Only the big pictures, anything larger than the slice size, is going to be a problem. So if you're on a LaCie drive, 256 might be the number for the slice size. All your pictures up to 256K are going to work, or may work. Not all of them. That's why we need a sample, because they may be at boundaries of the disk. We have made disks in the wrong order. We may have the beginning of a cluster in a different spot on the disk because we have the disks in the wrong order, something like that. Does that make sense? All right, so now click scan and let that go. I'm not going to save the data. I don't want to save the data. This is strictly a test. Now, you'll see it'll start scanning across the drive. And we've been very specific about what we asked for. So there's this little legend down here at the bottom. And your legend has something called specific file documents. Those are the items we asked it to carve. That's what it's adding up there, is our selection for carving. Yeah, it may be recognizing that I have NTFS and then I have fat tables and all such stuff. It may recognize that I have that stuff. But what I care about is only the JPEGs that I selected, and so I'm watching that number. And since I don't need the whole drive to process, this is how I'm being quicker than everybody else at solving this. As soon as it gets down far enough that I've got a good selection of the content, I'm going to hit the stop button. I'm not going to let it go. So when you get to 2000, you hit the stop button. Okay? So if you see that number 2000 or around 2000, then you hit the stop button. And around here it'll tell you where you're at in your array. So I'm at 1 gig out of 16 gigs right now. And so now it eventually will hit, because most of the time it's like operating system data, then you've got some boot stuff, blah, 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 and then finally you get to a chunk right here that'll be like users data. And that's where all your pictures will be. So I'm at 2000. I'm going to stop, and I'll wait on you guys. And just so you can see where that was, that scan information is still here. It just switches tabs. But that's how far I made it. So I made a little more than, I think I made a little more than 2 gigs into the drive before it found whatever it found. How about you guys? Everybody stopped? Everybody made it far enough? Nope. Let me know. Some machines are slower than others, or whatever the image is that's on there. Did you get there yet? No?
1 gig in,
Okay.
120.
Yeah, a little spike after a little bit.
Yeah, all of a sudden, it'll just be. Good? No? This is why we only have 16 gig images, because if it was like 4 terabyte, it would be like, yeah, it's a good real world example, but your real world example is I have to wait 30 minutes.
Cranking.
Huh? Yeah, it's cranking now. All right, so any second you should get to 2000. Good? All right, and then hit yes to stop. Did it do that? Okay, so then it switched back to this view, right? Like it switched back to this. Now, what we did was we built a table of extra found files. Those are our carved files. They're useless to our recovery. We're not using them for the recovery. We're not going to use any of that stuff. We're only figuring out our algorithm. That's it. So do not accidentally decide this is your recovery. These are just so you can figure it out as quick as possible without waiting 5 days. So now, double click on extra found files, and it will open up a new tab with your JPEGs. Now, all of your other stuff is still open. It just made a new tab. And this is confusing for some people, but basically you can switch back to any of your previous stuff by going back to device view, and it will take you back to where you were before. Okay? So you can still go around and do all the same stuff you were doing. But let me tell you this, I promise you, this is another place everybody screws up. When you're doing this in real life, even the best of us, I promise you, the best of us, if you do not clean up the tabs as you're going through the process and get rid of them, you will accidentally use those or think that that was your new result. So you can right click on a tab and say close. But don't do that now. The whole point being is that as I back out of this, when I've figured out it isn't my answer, make sure you close your tabs when you go back. If you don't, I promise you, you will suffer the consequences later. Sooner or later, that's going to happen. So right now, we're going to look at our pictures. So go to the digital JPEG camera pictures. Now here's the best thing to do is to sort by size. So if you come over here and you click on the size column and you click it twice, it'll put all the biggest files at the top. Now these will not work a lot of times. Depending on how bad your RAID array is, you just may get corrupt files, you can't open anything. You can look at them in an hex editor. So you can come over to a file, you can right click on it, and you can say view, edit, and bam, it pops up in a hex editor. So even if you can't open the file, you have the ability to examine it in hex as the logical reconstruction, okay? So like in this particular case, I can see right away by clicking on the first file and right clicking, I've got a JPEG with EXIF information that came from a Canon. Now maybe part of the file's corrupt because I don't have all of the content from the right locations. Does that make sense? But I can see at least it's not a false header, that I don't have false information. Everybody know what I did? Good, Tim? Mm-hmm. So I really am just looking. I'm not editing stuff. I'm just going to close that box and go back to where I was. Now, what is the number that you guys have at the top of your list of files? Is that what you all have? What do you have?
I have 1197.
1197. What's your next number?
2587.
What?
2587.
Okay, so you got more files than we got. 25. Do you see a 632 somewhere in your list? Because if you let it run longer, you'll have more files. So, how many you have?
2000.
What? Did you sort by size?
I did my.
Oh no.
I
So
want 600 something.
oh no. So this is why. Hit click size. No, right there, size column, and then it'll sort by size. Click it, and then click it again. Now all the big ones will be at the top. Right?
Yeah.
Or did you have that?
I had that.
Oh man, all right, well. 6. Okie dokie. Go back to your configuration. Let me see your configuration again. Let's just make sure we had the same. Okay, no. All right, so remember when I said the one thing that happens to people a lot of times is you have to watch where you're clicking. So you processed the image file. You did not process the RAID array.
Okay.
So that's why yours are down here. So come up here, right click here. So you've got to make sure you're on your reassembled RAID array. And so this is a common problem. Everybody does it, no matter how experienced we are, we'll mess it up sooner or later. Now, right click and scan. And now you want to do the scan of the RAID array. So you do exactly the same thing we just did, but you're doing it on the whole thing instead of just an individual thing. Okay. And then file type, make sure your file, just double check them and make sure it's just JPEGs. Yep, okay. And then go. Okay. What about you guys as far as numbers go? 632, what was it?
Yes, 15.
Yeah, so you guys have a little bit more? You too? Yep.
32.
And you got 632 in your list? Okay, so we'll give him a second. And then they'll catch up. So, you guys just want to take a break for a second while his is running, and then when